Good morning, everyone. Hi. What a warm welcome. Well, welcome to RailsC with me, where we're going to learn to turbocharge our use of the interactive console together. I'm Sweta Sanghavi. This is a picture taken of me at my birthday. I'm a senior developer at BackerKit. We build software to help crowdfunding creators both build community and also fulfill their projects. If you've backed a project, you might have gotten a survey from us. Check that inbox, might be BackerKit. I started Railsing after a previous career as a life science consultant. And in my early stages of learning Rails, that's when I grew to really love the console. And it's my goal today to leave y'all also loving this tool that we all have at our fingertips. The console provided an easy way for me to get to know the Rails environment and understand Ruby further. So today, we're going to start by taking a deep dive into the console and checking under the hood to look at what enables us to use the features we get to use it for, like storing context, evaluating Ruby, and the interactivity we've grown to expect. Then we'll talk about tactics to really supercharge your use of the tool into becoming super product developers. So let's start at the top. RailsC, what is it? So this console command gives us a way to interact with our Rails application from the command line. It gives us access to the data that's underneath our application and change it without loading the UI. We're able to use gems and libraries to facilitate our use of grabbing data, such as active record. We're able to run queries and understand the state of the users or other objects in our application. We're also able to actually define and execute Ruby code in our console. So let's talk about why the console is such an amazing tool. Well, it allows us to evaluate a piece of code in a specific context. We're able to really zone in on a method or even a class that we're wanting to learn more about. It requires very little setup. You kind of get it right out of the box, and that context is configurable. You can define classes, methods, variables, other things you need to support your exploration of your application. It gives us really quick feedback about Rails functionality. We can quickly see human-readable errors when we're trying to do something. And so today, we're going to use the console to learn more about the console. How is it able to do all these great things? Well, let's find out. Underneath the hood, RailsC actually just uses the IRB console. Perhaps like me, when you first started getting introduced to Ruby, you used the IRB console to get access to some Ruby code. So our console uses IRB under the hood as well. When we spin up an IRB console, you get all the core Ruby libraries. It's really fast and really great if what you're trying to interact with is within Ruby. You're also able to import Ruby libraries into your IRB session by installing a gem and then requiring it, or even requiring other Ruby libraries you've defined. But sometimes when you're using the console, you don't just want to install every gem that's included in your Rails application and not want to keep track of what versions your application is using. So if you want the gems required by your gem file, Bundler has a solution for us. We can call bundle console to spin up a console that has access to both the core Ruby libraries and gem code at the version specified in our gem file. But sometimes that doesn't cut it either. And so when we want access to our whole Rails application, we might actually spin up the Rails console, in which we're going to get access to a full Rails environment, including the auto-loading and the initialization of your application. Kind of everything you expect in your application. So let's talk about some of the features that make the console so effective. Let's start with storing context. So if we try to call a method or variable that our console doesn't know about, we often expect this error, like an undefined local variable or a method error, because our console doesn't know what full name is. But we know that we can actually store context within our session. We can define a method like full name, and then when we try to call it, we're actually going to get access to that method. So here we see the evaluation of full name. Well, how does it do that? Well, IRB uses subsessions to save and differentiate context. When you spin up a console, by default, you start in a subsession in the context of an object called main.irb. You might see this familiar main in parentheses, kind of indicating the context you're in. So anything you execute in this console is going to run in that main context. Let's start playing with how subsessions work to understand more how subsessions are used to store context. We can actually use the command IRB to spin up a new subsession. And you might see over here the number 1 that's come over here because we're now in a new subsession 1. There's a command jobs that's going to output the subsessions that are in our current session of IRB. And when we see that first one that we started off with, the 0, and we have subsession 1 as well. Okay, cool, so we've got 2 subsessions. Let's figure out what's shared and not shared between the 2 of them. So let's go back to that first subsession we started at by using the command fg0. And let's set a variable display name and set it to the return value of calling full name on Olivia Rodrigo. Cool, so now in subsession 0, we have this variable display name. Let's switch back to subsession 1. When we then try to call display name in subsession 1, we no longer have access to that variable. However, interestingly, when you call the method full name with 2 new parameters, we do have access to the method that we had defined in subsession 0. So how is that possible? How do we have something that can connect the 2? Well, another piece of the puzzle is the concept of a workspace. So workspaces keep track of subsessions, and each subsession is responsible for keeping track of context within that subsession. So workspaces are the top level above subsessions. The way we can think about the context is the context keeps track of the execution context at a particular place in our program. So let's talk more about context. Well, when you load up a subsession, let's talk about the main kind of top-level context. You have access to the instance variables, instance methods, and the concept of self. When we think about all of that in totality, we call it the execution context. And in Ruby, you actually have access to context through the binding object. Binding is a built-in Ruby class whose objects can encapsulate the context at your current scope. So that's what's going to give us access to the variables and methods at the specific point in context. We can actually pass the binding object as an argument, and so we can pass context around, which is how we're able to instantiate a subsession at a particular context, like we do when we might call binding.irb, a debugging tool that you might be familiar with. So we can pass context around to allow us to evaluate code at the particular, in that execution context. The next feature I want to talk about with the console is parsing Ruby. If we go back to our full name example, we see that you're actually able to evaluate Ruby code in the console. So the console needs to parse and evaluate that code. How does that happen? Well, before we talk about how that's enabled in Ruby, I want to take a moment to talk about abstract syntax trees. Abstract syntax trees are a low-level representation of a program's mechanics. And so a parser might take Ruby code and translate it to a syntax tree. And parsing it into a lower-level representation allows it to convert from one language to another. Parse trees are typically built out by a parser during that source code translation and compilation process. So we can think of it as a low-level representation of our program. So let's talk about that in Ruby. In Ruby, we actually have a library called Ripper that gives us a window into how Ruby is parsing our code. Ripper outputs the tree that Ruby is using to parse. So it's providing us an interface to take a look at that. You can return different kinds of trees from Ripper. And since we know we have all of core Ruby available in our console, why don't we take a look? Ripper provides us an sexp method, which outputs a symbolic expression tree. We're going to see what that looks like. And so we can see with this method signature that sexp will take your source code and evaluate for us. So let's take a look at that output. Let's call this sexp method with our method definition of full name. Kind of a lot, but we can see there's symbolic expression of our program in a data structure of array of arrays. Let's take a look at it step by step. So when we look at just the beginning, we see the symbol program, and we see our def keyword. So we're starting to define a new method, and it's outputting that program symbol. Next, we see this variable ident, which stands for identifier. And so we're instantiating full name, which is the name of our method, as a variable. Let's look at the next piece of this. So we see that paren kind of in symbol form, and we see a new array of params. And we see that first name and last name, the two parameters we're passing into full name, are also instantiated as variables that we're going to be able to access. Already, as we start looking at the output of Ripper, we can kind of see the utility of some of the keywords that we're used to defining methods with, like def and putting our params in parentheses, etc. Let's look at the method body, which is signified by that body statement keyword or symbol. Within that, we can see the two local variables, which are represented by the var ref, of first name and last name. And you can see that in the middle, there is the symbol of the summation. And while we might not understand all of the pieces of what Ripper is outputting, we're starting to see how the parsing of Ruby is happening, how it's taking our method definition and converting it into this data structure that it's going to use down the line. This is something you can try yourself in your own console, since you should have access to Ripper as well. So I invite you to take a look at a method definition or evaluate some code and play around with it. The last feature I want to talk about our console is the interactivity. This is a GIF that is on the Readline GitHub, but this might be a familiar way that you interact with your console. We're pretty used to being able to basically use it as a text editor. We get indenting, we can get syntax highlighting depending on what version you're using. You're able to hit Control-A or Control-E to navigate through the line. And these commands are pretty familiar across shells. And that's because they're often provided by the same source library called GNU Readline. So this library was released in 1989, and it gives us some of the inline editing and history capabilities that we're used to seeing across shells. It's used in other shells, and it gives us both the input history and some of the shortcuts of actually navigating lines of code you're writing in your console. In Ruby, that functionality was provided by Readline, a line editor that was abstracted from the GNU Readline library. And it's a C library that ships in standard Ruby. And that's what also gives us that same completion and access to input history that the GNU Readline gives us. It also includes some additional functions that maintains a previously entered list of commands and allows you to recall and re-edit those commands. One drawback of the Readline library is that it can only be used when the GNU Readline is installed before Ruby builds. So to get around that, Itayangi Sakura built a pure Ruby implementation of this library and called it Readline. This is shipped in IRB starting in Ruby 2.7, and as you can see in that GIF, as of Ruby 3.0, it accommodated some multi-line editing commands and auto-completion. I think it's really fascinating to watch how a software library that's used in programs outside of our Ruby workspaces kind of made their way in, and how we've integrated into work tools that we use on a day-to-day. All right, are we ready to turbocharge? In this section, I want to talk about how we can use the console to make us really expert product developers. Some of the superpowers of Rails C that I want to go through is how we can use it for performance improvement, for debugging, and our day-to-day product development. So let's first talk about performance. We might have tools like alerting or New Relic, et cetera, that will provide us transaction traces of pages that are taking too long to load. But even after I get that kind of input, I still have to do some debugging to really figure out what changes we're going to need to make load time acceptable for our users. Well, once you start getting that breadcrumb, the console really excels at allowing you to zero in on that code and figure out what's going on under the hood. One feature and bug of Rails and Active Record is that scopes can hide a lot of complexity. You might look at your code and see something like project lead.sweetspot with aware query and not actually know what's going on in that sweet spot method, and it could be easy to overlook. When we have a case like this where we're wondering, is this the culprit of our performance problems? Our console is really our friend here. One thing we can do is use the benchmark library to check out what is the actual runtime of this. Benchmark is, the measure method is gonna output how long it took to execute, and it gives you the third output, the real time in seconds, which is something that can be useful. When I'm wondering if it's a specific line of code, and after you benchmark it and you've proven it does take a long time, another tool is just commenting it out and see if your page loads way faster, because it should be way faster. So let's talk about, once you've honed in on a particular piece of code, what might you do to start solving that bottleneck? Well, we have a method toSQL that we can run in console to see what the underlying SQL is of any active record query. This helps me take a quick scan to make sure that I understand what the query is doing, and there isn't something surprising in there like a joins or something else. We can also use this method if we're trying to confirm the syntax we've used is correct. Just throw it in console, double check. Sometimes a SQL can be easier to parse through. Another tool that's really useful is the explain method that we also can run on an AR query object. So let's go through what that outputs. Explain will actually run the query because of eager loading, you might need to actually trigger the query to see what the runtime is. So it will actually execute the query, and will output the query plan, which we see at the bottom. The structure of the query plan is a tree of plan nodes, and it's going to show you what scans are necessary to complete this query. This can be really useful to see if an index can help you, if you're seeing a sequential scan that you want to add an index to, et cetera. One issue with some performance debugging is sometimes you really need the production console to mimic what's going on for your users. Sometimes you need the size of your data to really prove that that's what's taking a long time. So let's talk about using the console in production. Spinning up a console on production gives you access to the database that is on production and gives you the context of production. We should really use this tool with care, knowing that any changes we make to data are gonna stick and be in the production console. But when we're mindful of that, this can be a really effective tool. You can run benchmark on production or any of the other console tools we used if you want something that's specific to your production console. If you're worried about some of the data changes or don't really even want to think about it, console gives us an option of sandbox mode. So you can pass that sandbox flag in, and any changes you make to data are going to be rolled back. So let's take a look at what that looks like. When we spin it up, we automatically see any modifications you make will be rolled back on exit, which is comforting, but some of us might want to confirm that. And so let's take a look at my local database. I have one project lead, that I'm going to delete here. So we can see at the end the count is 0. When I exit out of this console and spin up a console again, we can see that that record has been rolled back or has come back. Let's talk about when you actually do want to make changes to production. It can be really effective to console into production when you need to make some fast changes. There might be an edge case that exists on production that's affecting your users, and perhaps you don't want to wait for deploy to actually make the fixes yourself. Again, when being mindful about how the changes you're making, it could be really effective to quickly be reactive to some exceptions or anything else you might be, user reports you might see. One tip is if you're making some changes, try to latch onto that kind of parent object. As an example, if there's a specific project whose users are in some specific edge case, like get your users off that project, et cetera. Really make sure you're scoping your change to that particular case. It's also really useful for debugging. Sometimes when I see an exception roll through and I don't quite understand how a user is in that state, you can console into production and check out the data, check out that specific context without having to pull it down. You're also able to monkey patch into existing classes if you want to run a script or a method that you've defined. Please test it locally first. Another tool that you can use your console for is for fast experiments. There's been many a time where I'm pairing with somebody and we're wondering, what's like the first value of an empty array? Don't ask, just ask your console. You have this tool available to you, and using it within your development process will answer these questions for you quicker. The last point I want to make is informing product decisions and impact with simple queries are a huge superpower. As developers, we have access to active record and our console on the reg, and we can answer data questions really quickly for our product organization. When you're shipping a feature and you come across an edge case, you can quickly ask, how big of a problem is this really? There's been lots of times when there's an edge case that comes up and you query the data and you know that it's so small of a group that a manual solution might actually be the better one. When we as product developers can make those changes or choices, it makes us really powerful. Similarly, if you've shipped a feature, let's say 3 months ago, that was supposed to be really groundbreaking, it can be useful to check how many folks are really using it. Use that data to inform your decisions, and it can help you figure out why not, or ask that next question of why is it perhaps lower than you expect. I'm going to finish up with a little cheat sheet, some commands that I wish I knew. We're going to start with a perhaps straightforward one, but an important one, Command K for clearing your console. There's been many a times where I'm scrolling through Rails logs, trying to connect an action that I've made in the browser to a log. Save yourself the time, because I've also made the mistake of thinking I've spurred it, but I hadn't. Clear the console and then do whatever you're going to do in the browser to make sure that that reaction is in response to the action you're testing. When we're in the console, we don't get the auto-loading that we usually expect from Rails. And so if you're changing code in your code, you're going to have to reload in your console to get access to those code changes. Sometimes if I'm testing a script or something over and over again, I'll prepend the call with reload so I can quickly just press up and enter and quickly test, am I getting the response that I'm expecting? know that after calling a reload, you're going to need to reinstantiate any objects that have changed due to your code changes. If you've ever tried to grab a piece of data but then forgot to save it in a variable, I've got an answer for you. It's the underscore. Underscore is always going to save the last executed thing in your console, and so it allows you to do something like that last line of saving a variable that is equal to the return value of the previous statement. Oh, man. And last command is the reverse command search, the Control R. You can use Control R and start typing a command you've used previously, and perhaps you've forgotten the syntax. And you'll see some of the previous hits to previous commands you've ran. If you don't at first get the one you're looking for, you can hit Control R again and scroll through some of the other hits. Once you've found the command you're after, you can hit return and it'll execute. Fun fact, this is provided by Readline. I've put all these commands in one slide for you in case you really do want a cheat sheet. And to finish up, I have to thank BackerKit, whose support in me coming to my first conference a while ago inspired me to even speak. If you like pairing, if you like the crowdfunding space, tabletop games, come talk to me, we're hiring. And another shout out to WNBRB, a virtual community for women and non-binary Rubyists. We actually have a working group that goes from proposal to dry runs, and without their support, this talk wouldn't be as good as it is. Well, thanks everyone. Thanks for coming to turbocharge with me. If there's anything you saw in this talk that you end up trying or looking under the hood even further, let me know. I'd love to know what you took away. Here's my email and my handle. Thanks, have a great RailsConf.